Hello, everybody, and welcome to episode number 12 of I Wish You Were Dead, a podcast about things that used to be alive. My name is Mike. Gavin is back in the fold this week. Thank you so much, Gavin. How are you doing?
I'm sleepy. Yeah, so this last week, if you did not listen to Mike's wonderful little 1 to 2 minute spiel that he put out last week, I was real busy finishing most of the writing. There's probably 1 or 2 small edits that my advisor will have for me when he gives my next draft to me, but he essentially told me that it's basically done, which was literal music to my ears. So yeah, that's what I was doing last week. And funnily enough, as you might have saw from the title of this episode, we're going to be discussing my master's thesis in some pretty good detail. So hopefully you're excited for that. I'm excited for that.
This is an episode I've been looking forward to for quite a while. And last week when I found out that we had to kind of take the week off just to make sure you had enough time to get that done, I was thinking to myself, either we're going to be discussing this next week or we're just never going to get this episode. We're never going to be able to hear about it. So I'm super excited. I'm super thrilled to be able to actually hear about what it is that you've been pouring the last. I mean, how much time realistically? So this been the last year of your life? Has this been the last 4 years of your life? Like how much time has really gone into this? All things considered.
We can talk a little bit about like the process once we get into the actual body of the episode. But first, we have a couple announcements as well as our typical This Week in Science. So with that, what do you want to do first, Mike? This Week in Science or a couple announcements? Let's do. Actually, I withdraw that. Let's do announcements first. So
I'm just here.
We have a couple. Yeah, I'm talking to myself at this point. So we have a couple interesting announcements. So the first is, if you look in the show notes of this episode and future episodes going forward, we will have a couple of Google Forms for a couple of things. The first one will be for if you all have a particular topic in mind that you would like us to discuss. There's a form for that. So whether it's one particular group of animals or one geologic time period or one geologic event, anything that you think is interesting, it could be as simple as like horses, which we'll talk in a fair amount of detail about in this episode because that's the main group that I work with. Horses have a really neat evolutionary history, as well as pretty much every other group of animals does. So I'd love to be able to just have an episode about horses or about dogs. That'd be neat. So if you have any suggestions, there'll be a Google form for that down below. There will also be a Google form for if you are in sort of these sciences and would like to be on as a guest. Mike and I would love to have you. There will be a form for you to fill out. Just sort of expressing your interest and also for us to learn a little bit more about what you do in your research, even if you're not, a practicing researcher currently. That's okay. If you are an interesting sciencey person, we'd love to have you on. Any thoughts on those, Mike?
Am I allowed to talk?
Yes, no, Mike, I grant you permission.
No, so this has always been kind of one thing that we've wanted to do for a little while now. I know we have number one fan of the pod, Fia, has talked about at some point she's been doing some cool research and some cool sciencey things down in the South that I'd be looking forward to hearing. But that's kind of one thing we've wanted to do for a little while now, is just have other people on to talk about things that that certainly I'm not an expert on. And even you, Gavin, for as much as and as many things that we talk about on the show, there's always a new stone to be uncovered. And it's always, the best way I can phrase it or to put it is, you can take the most boring subject in the world, but when you've got someone that's really passionate about what it is they're doing and really seems to love what they're talking about, like, it doesn't matter. It's not boring at that point. It is just exhilarating almost to be able to hear that. So if there are people out there that, whether they are a practicing scientist, whether they are, a famous person, whether they have a passion project, whether they have a passion project, and it's like, I've as a side hobby, I've dedicated a bunch of time to learning about this particular thing. That's kind of what this show is all about, is we would love to be able to hear from you and talk about something that we might not have otherwise either done justice to or done at all. So I am all on board with trying to talk about, things with a few other people on the podcast.
Absolutely. And then lastly, for announcements, I think we've teased it a handful of times as well, but I have since actually launched my blog that I have running for a couple weeks now. Because of obvious reasons like writing my thesis, I haven't been able to post on it all that much. But there are 2 articles that I have written, one of which we'll be sort of talking about next week, so a little bit of a teaser for next week. But the blog will be also down in the show notes, but is deepdigs.net.
Which is a great name. Great.
Oh, thank you.
It's a great website title.
Deepdigs.com was taken, unfortunately. But .net also makes me feel, I don't know, there's just something about .net versus .com that just seems more sort of like official almost. I don't know. Maybe that's just me.
I mean, one of my favorite things is every time I look at website domain registration, in addition to your usual .com, .net, .org, there's just
so many weird ones.
It's so many. You can do like .wine or something. Like it is, like I think there was, this will be an inside joke, but there was one time I was going to register a website called EasterWednesday.wine. That like there are so many weird ones, and so while .com .com may have been nice, deepdigs.net, like there's something about that just rolls off the tongue a lot better. So this will be a nice way to kind of keep up with where you can share things with us, more than just weekly, I suppose. And hopefully that'll give us even more episode ideas as we go on. But that'll be a nice how often are you updating that? Is this once or twice a week is the plan?
So ideally once a week. That's probably not going to be realistic until my life is a little more stable. When is that ever going to happen? I don't know.
But even still, we're getting our weekly dose of Gavin through the podcast, through an audio medium, and then hopefully a couple of times a month you'll be able to see something he's written, which is almost as enjoyable.
Yeah. So once again, there is currently 2 articles up. One about fieldwork and how I think it should be changed going forward with all the lessons we've learned about COVID and how we can make fieldwork a lot more inclusive. Basically what we've talked about in our various fieldwork episodes. And then also one about a very interesting dinosaur specimen that was discovered, preserving a particular piece of anatomy, which we will be covering next week. But
oh boy,
with that, we can get into This Week in Science.
This Week in Science. All right. So how far back are we talking here?
So this is, once again, on a weekend, so we have a twofer. So this is coming to us from March 6th and 7th. So March 6th, 2002.
Ooh, I think this is as far back as we've gone in This Week in Science.
I think so. But this one is titled Revolutionary Gene Editing Process Coined CRISPR.
I've heard of this.
Yeah. So, found in 1993, but first named in 2002, CRISPR, which stands for Clustered Regularly Interspaced Short Palindromic Repeats, is a form of organic programming. I mean, that's not how I would describe it, but okay. That works by implanting organic structures with custom targeted code. Again, not the verb, like the words I would choose, but whatever. With this, scientists have proven capable of doing everything from lengthening telomeres, which are sort of like the little caps. Like telomeres are essentially the aglets, so like the little plastic thing on the tips of your shoelaces, but on chromosomes that keep your chromosomes from unraveling. To eradicating HIV-infected cells within the human body.
As I'm thinking...
That is... Go ahead.
Just thinking about how, you disagree with some of the phrasing there. I'm thinking as part of your blog, you could make your own calendar for This Week in Science.
That's true. I could do that.
Yeah. That'd be just another really project to add to your list.
Yeah. It's not like I don't have enough.
Yeah, of course not. Have we discussed CRISPR on the podcast yet?
Maybe a little. When it came to
like dinosaurs,
some of the Jurassic Park, like de-extinction type talk. I don't think we've mentioned it by name.
Right.
But
that would be the kind of thing I'd love to do sort of a deeper dive on. I'm not sure quite how in your wheelhouse that is, but that's kind of one of those things that
I've taken 2 genetics courses, so once again, something that I probably know more than the average bear about,
Gotcha.
but yeah, genetics was not my forte. Uh,
If you are out there and you know something about genetics, please fill out that form, and maybe you can be a guest
Absolutely.
on the podcast because we would absolutely love to have you here. And then was there a
CRISPR
second one?
honestly horrifies me. Yeah, there was a second one. So
Okay.
it goes from like CRISPR being, in my opinion, completely horrifying with what it can do to something
Yes.
that honestly is like such like a question that you would get from like a 2-year-old. So this is from March 7th, 2019.
Ooh, okay.
How much does the Milky Way weigh?
So now
So
we yes.
how much does our galaxy weigh?
I love that
Doesn't that
question
seem
so
like a
much.
question you would get from a kid though?
It's the kind of question I would ask. So yes, exactly. Like we need to define what the
Yeah,
word
so
"way" means. Like there's oh my god, I love that.
astronomers from NASA's Goddard Space Center announced that they had calculated the most accurate measurement of the Milky Way galaxy's mass to that point using the Hubble telescope and satellite data. Roughly speaking, the Milky Way weighs about 1.5 trillion solar masses,
So that's
though a massive portion of that is represented by unseen dark matter.
and by solar masses, that is like the mass of the sun, correct?
Yes.
So
Yep.
the sun was at 1.1 trillion times.
1.5 trillion.
1.5. I and here's the thing. My initial reaction was that's too low, but then I remember how big a trillion is, and I'm like, maybe it's not too
Yeah.
low. Yeah, maybe that's about right actually.
But I do like how it points out that probably the majority of that 1.5 trillion solar masses is dark matter, which is a concept that's very interesting to me, even though I don't understand almost anything about it. But it's
Right.
basically just a type of matter that we cannot really see. I think we can just barely detect it sometimes, from what I understand,
Yeah, my understanding
which
was
is not
always
much.
that it's we can observe I think it's like 4 to 5% of the universe, and then we don't really know what dark matter is, so we just called it dark matter. Dark as in like we don't know, and then there's also dark energy. That was always kind of my understanding, was that we know that it's there, we just don't really know anything about it.
In my limited physics and like especially like space physics experience or knowledge, I think we don't detect it itself. I think we detect
Its
its
effects, probably,
gravity.
yeah, which is
So
even weirder.
I think it was like, things were behaving in a way that like the math didn't work out with
Right.
like, okay, this comet is traveling like in at this speed in this direction.
Hmm.
It should move in this way,
But it's
affected by
not.
the gravity of some star, but it is just very slightly different in a way that we couldn't explain until we were like, oh my god, there's just this dark matter that we can't see that's literally everywhere.
Which is
Including like, I'm positive that there's probably dark matter like in my bedroom here with me currently. Like, I'm positive that that's true.
absolutely, and that is it
I
is
don't know what that means, but
it is it and that's one of those things that unfortunately is probably well beyond the scope of this podcast, but it is something
oh,
that I would love
absolutely,
to.
yeah.
Yeah, that is I would love to do another one of these podcasts with a space person and just have them explain stuff to me.
Like we had at the beginning of sort of our our episode about the different types of vertebrates. We have a content warning here for some pretty technical science. It'll sort of depend on, I don't really have too much of it scripted out, so it'll be just sort of how it rolls out of my mouth. But there's potential for some pretty technical science going on here. So, my project is about one particular fossil locality. Some people might do it about even like one particular specimen or one particular group. They might try and figure out how different species in like a family are related to one another. Mine is about a specific location where fossils were found. So back in sort of like the mid to late 1950s, this area was a gravel quarry down in central South Dakota. And as this company that was like, getting this gravel to use it for various things like roads to make cement out of, they noticed all of these bones just sort of falling out of the gravel as they were putting it in like the trucks and stuff. So they called my school, because my school, even back then, was pretty well known for paleontology, especially in the state of South Dakota. And it turns out it's like a pretty diverse assemblage is the term that we call like a collection of fossils is an assemblage from the late Miocene.
That's a great term. Late Miocene.
Yeah, so we break up a lot of sections of geologic time, whether it's like a period like the Cretaceous period or an epoch like the Miocene, into just like early. Sometimes there's a middle in there, but there's like early, middle, and late.
Right.
So this was the early part of the late Miocene.
It makes total sense. It's just fun to hear out loud.
Yeah. So roughly 12 to 10 million years ago ish. So obviously, this was an economic operation with this, gravel company. So they weren't going to just completely halt their operation and lose money to let these pesky scientists get in there. So
how dare they?
I know, right? How dare they try and collect some fossils while we're trying to make money?
I know. What's more important here?
The fossils. So
your voice.
What
there.
they did was they had people on either side of like the conveyor belt. So they would basically take like an excavator or something, whatever version of that they had in the 50s, I don't know. And they would just like scoop up a big, bucket full of gravel and dump it on a conveyor belt on the way to like a crusher that would crush up the bigger pieces of gravel into smaller pieces that could be better processed. They would have field workers on either side of this conveyor belt, literally hand picking fossils off of the conveyor belt before they got to the crusher and were destroyed. And then they also had somebody raking through the scrap pile to see what they could find.
Okay.
So if you're thinking that, he's at a school that's pretty well known for paleontology, so he must be working with really nice specimens, right? No, these specimens are...
You were going to be thrown out, basically, literally.
Well, they're all completely destroyed. Life gets a lot easier if you have what's called an associated skeleton. So articulated is when all the pieces are together in the way that they would be if the animal was alive.
Right.
Associated means, okay, we can tell that these are from the same individual, but they're not together like they should be.
Okay, and that seems like something you can work with.
Yeah, absolutely. And then isolated is when it's just like a single tooth with nothing else to it. The vast majority of specimens in the collection that I was working with were isolated, which is unfortunate.
It also means a lot more work for you.
Absolutely, it does. So a little bit of background about the time period. So the Miocene, as we talked about in the second part of our 600 million years and technically 120 minutes, but 60 sounds better. So the second part of that, we talk about the Miocene. The Miocene period, or epoch, is when here in North America, grasslands really started to expand into approximately sort of the Great Plains that we see today. And because of that, a lot of, grass-eating animals instead of like leaf-eating animals started to diversify. And at the time, the main grass-eating group in North America were horses. So horses go absolutely insane during the Miocene, particularly during my part of the Miocene. And so, as I've mentioned a handful of times, there are different ways to break up time. all these different periods that we talk about, Cretaceous period with the dinosaurs, the Cambrian period way back, at the beginning of when life sort of like first majorly diversified.
Hmm.
Those are all based on stratigraphy. So those are based off of rocks, not necessarily fossils.
Right.
There's another system that I use a lot in my thesis called NALMAs, which is an acronym for North American Land Mammal Ages.
Okay.
So these are based off of fossils instead of based off of rocks. And
What is there an advantage of doing it this way?
it allows you to be more specific. And also it allows for a lot better correlation of different places based on what fossils show up there.
Mm-hmm.
So
Okay.
a lot of times, when you say, if you're correlating rock layers, so say you have a rock layer in central New York and a rock layer in like Illinois, one of the many things that you look at about that to see, okay, these two are actually the same, deposited at the same time, are the same type of rock. One of the things that you look at to say these are the same is the fossils, but you also look at a ton of other things. So you'd look at like chemical composition of the rock, grain size of the rock. You can look at various different isotopes of the rock. What kinds of minerals are there in the rock? So in order to say that these two formations are the same and from the same time, fossils are just one of the things that you look at with these like NALMAs, and like there's different ones. There's like a European land mammal age, South American land mammal age system. Recently, just in the last less than a year, they established an African land mammal age system, which is really neat.
And who's they?
That's a wonderful question.
That
So for
wasn't supposed to be a gotcha. I apologize.
no, I know. So there is, when it comes to stratigraphy and the actual like time periods and such, there is an international commission on stratigraphy. So
Okay.
they collect, yeah. So they have different people who sort of specialize in different areas of time. For example, my old advisor at SUNY Cortland, I don't know if he still is, but I believe at one point he was on the section of the International Commission on Stratigraphy that focused on the Triassic. So he was on like that like sort of subcommittee.
Right.
So he was one of the people who helped decide exactly when the Triassic and the different epochs within the Triassic period started and ended.
That's a wild job. That's wild.
Again, that's not his main job. That's not like but he's
but still being given
one,
that
yeah.
responsibility, like it's like, okay, the decision that we collectively make together will be read by children in dinosaur books for the next however many years.
And granted, by this point, it's pretty well defined. It's mostly just like if new evidence comes up, like new radiometric dating of like some isotopes from like the early or very late Triassic, says that like, so the Triassic starts at about 251 million years ago and ends at I think 199 million years ago.
Okay.
And there's, on any date that is given in geology, there's like a plus or minus
Right, there's
X
some error bars.
million years. Yeah. So if like some new data comes up or is published, suggesting either like that those error bars can be narrowed or that date should be changed by even like 500,000 years, which is not at all a lot in geology. They sort of review that and say, okay, should we change the actual boundary or shouldn't we? Granted, I'm not at all even close to being on one of those committees, so I don't know if that's actually how it works, but to my knowledge, that is roughly how it works.
It's a life goal.
Yeah. For NALMAs, though, I don't think that there is. I don't think that there is like an official committee. Most of the information that I have comes from a textbook that was published in 2004. And so people have been using land mammal ages for a long time. Uh, so, for example, I've got one of a really important source that I've been using for my thesis is from 1969.
Hmm.
So
Okay.
they have been using them, all the way back before that. So I don't believe that there is like an official body that changes or regulates when these are used. But the
It's a
way
generally
that they
accepted
work,
term, is what it sounds like what you're saying. It's a
yes.
generally accepted term, even if like you can't point to one organization. It's like they officially endorse this.
Well, so each Nalma, so each section of time does have a definition. So, for
Right.
example, the one that I worked most closely with is called the Clarendonian, and it's named that based off of uh, the Clarendon Beds. It's an area down in the Panhandle of Texas, which is where like the first deposits of this age were found.
Hmm.
So, the Clarendonian age is defined as so I mostly work with, and that's even further broken up into three sections. There's called CL1, CL2, and CL3. So the one that I work with, even within that most closely with, is CL2, the middle one. And
Hmm.
I don't know the exact definition of the Clarendonian, so when CL1 starts, but CL2 starts by the appearance of two, uh, they're called Barborophilids, which is a
Ooh.
family of predators that is we thought they were cats, but they're not quite cats. They're like cat cousins. They're like on that side of the carnivore tree, more closely
Okay.
related to cats than dogs. Yeah. Anyway, long story short, carnivorans are split up into, are they more dog-like or are they more cat-like? These happen to be more cat-like, so they are cat cousins. But two particular species. There's Barborophilus whitfordi and Barborophilus osborni. And so when those two species show up, then you know that that is the start of the CL2 section of the Clarendonian. And that's just one example. Every, you know, land mammal age, or even all of the subdivisions, have definitions like that.
And that, if I could take a guess here, and you may have already said this, but like part of the reason why you'd want to do this, if I could just guess, is like if you're in, like you said, two different places on in North America, like, and it might be difficult just by using rocks to figure out how old something is. You can say, well, this species didn't show up until this many years ago, so roughly we know everything at this this stratified layer is this old.
Yes and no. So we need to do a bit of a combination. Um, so, for example, there is a really, really well-known Miocene fossil site in Nebraska called the Ashfall Fossil Beds. If you are at all like in the Great Plains, it is worth going to. It is absolutely incredible
The Ashfall
because
fossil beds. I'm gonna look that up right now.
yes,
Keep
and
talking.
it's called that because there was a volcanic eruption somewhere in the Rockies that just dumped like tens of feet of ash on the Great Plains.
So I just
And
Googled
so
Ashfall fossil beds, and the fossils that are on Google Images right now, I don't know
they're
anything about fossils,
incredible.
but they look really cool.
They're essentially Pompeii and just buried in, I mean, really, like just buried in this ash. And so Nalma's sort of work in that we find one sort of like marker layer like that. And based on, doing some geochemistry and isotope stuff, we can figure out exactly how old that fossil layer is. And then we can use the fossils in that to compare to other sites. So most things, especially in the Great Plains generally has a really good fossil record for like the Miocene. Um, so we can see, okay, this species we know is a little more primitive than this other species, which means it came before it. So if we have the primitive species in the beds that we know, like with the ash that we know the exact date on, and then we find the more, the less primitive, the more derived species somewhere else, we can say, okay, so where this derived one was found came after that rock layer with the more primitive one. You see what I mean?
Yeah, that makes a fair amount of sense.
So basically, we just find these like really good places where we can get a nice geochemical date on, and then sort of hang our correlations and comparisons off of that one. So, unfortunately, my site was not that nice layer. So the whole purpose of my thesis was to figure out when in time this site was accumulated. So it was a channel deposit. So it's basically like a river. So it's like if you have a river that sort of, meanders and curves on, one of the bends, one side gets eroded, the opposite bank gets, stuff deposited in it. This is from one of those opposite side of the banks where stuff gets deposited.
Okay.
So,
so that's where your fossils were originally located, correct?
Right.
Okay.
So my job was to figure out, look at this site and then compare it to other sites around the Great Plains and figure out when exactly this was from. We had a pretty good idea, but it's like until you get in there and actually do it and do the science, you don't know for sure. And that would be easy enough if the animals in there had the right scientific names.
Oh, good. Oh, good. I'm confused. What's the problem?
As we've talked about, sometimes scientific names for things change. As we get new information, we might say, okay, this species, species 1 and species 2, we thought they were different, but now it just turns out they're the same species and just looks kind of different.
Yep.
Or this one species that we thought was one species is actually like 5. Sometimes that happens as well. Less often, but it does happen. And just over time, the names we call things change. And that's especially true with horses. There was a ton of work on horses done in like the late 80s to mid 90s. And so a lot of, pre that time, a lot of what we call different horses might have changed. Guess when the last work was done on this collection?
I'm going to go with 1979.
Very close, 1981.
Okay. So it's still early enough where the appropriate work had not been done.
Right. So,
which is perfect because it allowed you the opportunity to go in and do that hard work. So you should say thank you to everyone that didn't do the work before you.
I mean, it's not like they were doing nothing. Like they were doing other things that I'm sure were valuable.
They were valuable, I'm sure.
I don't know. So
what is value?
My job was to go in there, look at all the fossils in this collection, figure out what each of them were, and then, based on that, compare it to other sites around the Great Plains to figure out, say, we know when this one was and this other one was. Mine falls somewhere between them.
Okay.
Cool. There are approximately 1,200 or so individual fossils in there.
When you say, just a quick clarification, when you say 1,200 individual fossils, does that mean 1,200 like individual bones or 1,200 individual specimens, each with...
That's a very loaded question. So, and I want to be very clear before I say this. This is not a problem that is unique to the museum that I work with. This is a problem at basically every museum.
Okay.
But our collections need a lot of work. Meaning that in an ideal world, every single tooth, every single toe bone, every single leg bone would have its own unique specimen number.
Right.
And be in our database that we have online. That's not even close to true. For example, one specimen number in this collection that I work with has over 120 teeth in it.
Which is not the way it's supposed to work.
That is no. Because if there was one or two of them in it that were different, it's like, okay, how do you specify which of those two teeth out of that 120 I'm actually talking about?
And if you
In some cases, some of them were like, specimen number and then dash A, dash B. But in a lot of cases, that's just not how it works.
now, is there any way to go back in and like do the work that I assume you and other people are doing and reclassify these, or is that just a bureaucratic nightmare that like if you do it wrong first, or I don't necessarily want to say wrong, but if you have
Oh no, it's
120
wrong.
teeth, fair enough. If you have 120 teeth, under one sort of serial number, if you want to call it that, like does that make it just that much harder to then go back and change it later on?
Not hard, but very time consuming.
Right. Okay.
So actually, one of my office mates is actually on like a work study doing that as like a job, and like he literally sits at a computer with like we have a notebook of specimen numbers, and he literally just like sits, tries to decipher the person's handwriting, because whoever wrote those specimen tags had atrocious handwriting. Like as I'm working on like my own stuff, he'll just sort of like tap my shoulder and be like, do you know what this says? Because I don't know what this says.
You need,
But
you need like a second grade teacher to go decipher that, because a second grade teacher will figure that out immediately.
But yeah, so that is not at all how it should be done. It should have been each tooth, each leg bone, each whatever gets its own unique number. I can understand why they did that, because I'm trying to think. I think we are up to 6 digits for our specimen numbers currently.
Just your museum, or like in total?
Oh yes, just my museum.
Okay, that's what I thought.
If it had been done properly the entire time, we'd probably be in like 8 digits.
Good God.
The museum that I work with has so many specimens. Like it's crazy. And we're not even like that crazy large of a museum. So yeah, it's unfortunate, but sometimes I do get it. It makes people like my job harder later down the line, unfortunately. But I do get it. So my job was to look through all of these teeth and all of these bones and all of these, frankly, mostly teeth, which is good, because I think, as we talked about also in that vertebrates episode, with mammals, teeth are like chef's kiss. Teeth are great for mammals, because in every other type of vertebrate, they are what's called homodont. So most of their teeth are basically the same. They might be different sizes, but they are all roughly shaped the same. With mammals, however, as you might have noticed with your own teeth, you have different teeth. So you have incisors, canines, premolars, and molars. And mammals are the only animals that do that. So
really?
Yeah. And so a lot of mammals can be pretty easily identified, at least to their genus, by their teeth, with some exceptions, including a group that is in my collection, camels. I hate camels so much.
Because, can we have an episode just on animals you hate, like pandas and camels and everything else that you just hate? Humans are probably in there.
Oh, they are. Like, I literally on our list of on our Google Doc below my master's thesis.
That's right. I forgot about this.
The next bullet is why humans are garbage, which will be an episode at some point. But just going from horses, which, like I said, out of that, like roughly 1,200 total bones and or teeth in this collection, I would wager at least somewhere between 50 and 60% are from horses. Probably closer to 60%. And horses are very, very easily, at least relative to a lot of other mammals, recognized by their teeth or identified by their teeth. So that made my job partially easier. It's just like the sheer volume of teeth to look at. And for the most part, The teeth were, and on most of the specimens, were identified correctly the first time. So a little bit annoying that I had to double check it anyway, but that's some of the hard work that needs to be done in science.
Right.
Um,
Someone's got to do it.
and so, yeah, exactly. So, I spent my time looking at all of these horses. So I'll just give a quick rundown of all the different types of critters that I've got running around during this time period in this deposit. So I'm just gonna go in like the order of like the shelves because that's just how I have it sort of categorized in my mind.
Okay.
So for carnivorans, which are exactly what it sounds like, your meat eating, although not all of them are meat eating mammals. I have one felid tooth. Cats are not a group that is easily identified by their teeth, mostly because cats just sort of lose many teeth. Cats have, I think, 3 incisors, a canine, 2 premolars, and a molar, and I think that's it. Compared to the default mammal formula is 3 incisors, 1 canine, 4 premolars, 3 molars.
So they're missing a few.
Yeah, they dump 2 premolars and 2 molars. So, and it was a cat molar, and yeah, you can't really tell anything on that. I'm like, well, it's a cat. Write that down. We have some dogs. We have some members of the family Canidae, specifically members of the tribe, or no, this is a family, or subfamily, Borophaginae, which, if you are a student of Latin, you might know means bone-crushing dogs.
I'm not a student of Latin, but I believe you.
So these are dogs that essentially were doing what hyenas in Africa do, in that they are not sort of the long-distance chase-down predators that we normally think of dogs like wolves are. These are sort of ambush predators, incredibly powerful jaws that would bite open and crush bones and eat the marrow inside. Because bone marrow is very, very nutritious.
Right.
So dogs, but not doing dog things. And then we have the big boys called amphicyonids, which are colloquially called bear dogs.
Bear dogs.
Now, bear dogs.
Bear dogs.
And these animals are terrifying. They're not honestly that closely related to either bears or dogs. But they're very big. And I think I would honestly rather run into a bear than one of these.
Really? Bear?
Yeah.
Wow. Okay.
Yeah. Yes. So one of the specimens that I work with, has a canine tooth, like just the canine tooth, that is over like 2 inches long.
Okay, I believe you.
Huge.
I'm convinced.
Huge. And yeah, just big animals. These were like probably the like dominant predator of the time, at least in this collection. So that's it for like the meat eating guys, which makes sense because generally there are way more herbivores in an ecosystem than there are predators. So let's see. Then we get to the horses. So there are many, as I mentioned, horses running around at this time. This collection has, I think, 7. Yes, 7.
7 species of horses?
7 taxa of horses. So taxa is sort of a catch-all term that can be used to refer to species, genus, family, pretty much whatever level you're talking about.
Okay.
And I use it in this case because some of them I didn't have good enough material, like the specimens were not good enough for me to give it a species, but they were good enough to give it a genus.
Right.
So, and they ranged from, horses that were, medium dog sized to horses that were just about modern horse sized. which
Oh,
is super cool because everyone thinks of horses as these just big, sort of majestic animals, and not these little, German Shepherd sized guys.
right, like you think about horses as being out in the rural countryside, like needing quite a lot of space. You don't think of them as a suburban pet. And I'm sure that suburban pet is not the right way to think about them, but that kind of size is like that challenges my brain as to what a horse is. Thinking about a horse that size.
Absolutely. So the two small ones in particular from this collection are called Sued Hipparion,
Hmm.
which means fake pony.
Man,
Um,
I love scientists sometimes in the way they name things.
well, specifically, it's referring to there's another genus of horse called Hipparion that its teeth look sort of similar, or Sued Hipparion's teeth look similar to Hipparion. So that's
Hmm.
why it's called fake Hipparion, but Hipparion means pony.
Okay.
And then the other small one is called Calipus. I don't know what that means, but another small horse. And then ranges all the way up to Pliohippus, which is the big horse that I talked about in quite a bit in the Bone Wars episode.
Hmm.
So near modern horse size, not quite as big, but close. And all of these were grazing horses, so grass-eating horses. I have one genus of browsing horse still around called Hypohippus, and man, just looking at their teeth is very, very different. Horse teeth are very like sort of square and very tall, so it sort of looks like if you have like a rectangular prism, then
Hmm.
sort of curve it a bit.
Okay.
That's what a grazing horse tooth looks like.
Good. Wow.
A browsing horse tooth looks very spiky and very short.
Ooh,
That's the best description I can give without getting overly technical and using a bunch of terms that probably the majority of people don't care about.
I
Uh,
appreciate that.
um, but yeah, so after all this, this whole several months of work identifying all these several thousand, or over 1,000 anyway, specimens. Um, the majority of them did not change what they were
Hmm.
called originally.
Hmm.
Um, but like I said, still got to be done.
Of course.
And then I did some honestly quite simple statistics. There's a really great completely open source program. Anybody can download it called PAST, just PAST,
Okay.
and it's a very user friendly like statistical software.
Well,
And
that's nice.
I did some things called cluster analysis. So basically, I took my collection and just made like a big list of all the different species that I found in this collection, and then there's a big textbook that was published back in 1998, so it's a little outdated, but still generally really good.
Hmm.
Um, that has information about basically every North American fossil mammal that has ever been published.
Wait, that's a thing? Really?
Mm-hmm.
Wow,
It is
jeez.
called The Evolution of Tertiary Mammals of North America. I believe that's what it's called. And there's 2 volumes of it, one for macro mammals, one for micro mammals like rodents and bats and things like that. Um, and it even has like a whole list of collection or of localities in it. So I
Hmm.
just picked a couple that are around the same time as mine
Right.
and just went through and found every species that was found at each of these collections. And then I basically just put all of those lists in this software. And it basically gives you, okay, so this locality is most similar to this other one. The group made by those two is most similar to this third one, and so on and so forth until they're all sort of connected. So it gives
Right.
you which ones are more similar to one another. So I
Hmm.
did 3 different kinds of those just for robustness, different kinds of methods. Ideally should all say similar things if your data are good. Um,
And what did they say for you?
it worked out. Yeah.
Per-
So
Now, can I ask
We
you
were,
this question real
yeah, go ahead.
quick? So, if let's say it didn't work out, let's say you put that data in and you got a bunch of oddball answers, you got three different kind of results for that. Would that be like the end of your research, and you would have to go back to the drawing board and either pick a different topic or like go back through all that kind of grunt work, or assuming that all your grunt work was done correctly, would that result of this doesn't match up the way it should, would that be good enough to get to like publish your master's thesis just on that like something's weird about this?
So the first step in that would be trying to figure out why. And in fact, it did sort of happen.
Oh,
Where
okay.
the first result that I had made some sense, but not quite that much sense. So I compared my site to 5 other sites. And so, as I mentioned, there's 3 sections of the Clarendonian. There's the CL1, CL2, and CL3. So I picked one site from CL1, one site from CL2, one site that is mostly CL2 but goes a little into CL3,
Mm-hmm.
one that is CL3, and then one that is from the period or the Nalma after, called the Hempelian, from the first section of that one. Just so I had like a pretty wide range of places for mine to fall. And at first it fell closest to the 2 that were CL2, which made sense. But then the one that was CL1 was like the furthest removed. And I'm like, okay, that seems weird to me. So I went back and double checked, and I had actually made an error, fully on me in putting my data into this software. So
it's almost like a good thing that came up, so you were able to go back and double check your work. Like, I'm sure that sucked, but
yeah. Oh no, it was very annoying. But and then afterward, I made sure I double checked all of the other ones to make sure that I had the data input into this program correctly for all of my localities, and thankfully that was the only one that was wrong. So, or at least had some errors in it. So, so I redid it, and it came out and made much more sense. And so what you would do after that. So this was not my only like line of evidence suggesting that this site was CL2. I also had some morphologic information. So, for example, that I only had one anthocyanid, those big bear dogs. I had one species of those in this collection. And this species is really neat in that it has a clear change in morphology over time that we know, like, sort of when things happened. So, for example, by the time it gets to sort of the middle to late Clarendonian, it no longer has a third molar. Earlier specimens of the same species do have a third molar. So based on that, I could say, I'm like, okay, so it's either CL2 or CL3, because CL1 is the younger one, or older one. CL3 is the younger one.
Right.
So based on that, I could say it's CL2 or CL3, because early Clarendonian and then before that usually have a third molar. And then there was also a feature on the first molar of the bottom jaw called the metaconid that gets more and more reduced throughout time until at the very late Clarendonian, that feature is just pretty much gone. And mine, in the specimens that I had in this collection, it was still there, but it was pretty reduced. So I'm like, okay, so it's not the latest Clarendonian.
Right, but that gives you a pretty good clue that it's towards the end.
Or not toward the end, because if it was
I'm sorry,
gone,
the other way around.
Right.
Yeah.
So between the specimen, my specimens did not have a third molar, meaning that it was CL2 or CL3.
Mm-hmm.
But it did have that feature on the first molar of the lower jaw, meaning that it was not CL3. So those two combined suggest that it's CL2.
Makes sense.
You said that a little hesitantly.
I mean, I again,
like I said, this is a technical episode.
like, this is all reasonably above my head, but it does kind of make sense that you say, okay, we know that by the end of this, I'm going to call them periods, even though I know it's not the correct term.
Sure.
By the end of, this one given time period, we know that, it has lost this feature, and we know at the beginning of the time, this particular time period, it had this feature. And if this feature is almost gone, we know that we are almost, at the end of this time period, or the newest.
Right.
So yeah, I'm not going to pretend like I understand every word you said, but the general idea and the kind of work you're doing, that was able to make it through my thick head.
So that was one line of evidence, and then another one was just sort of what species were there.
Ooh.
The Clarendonian was a time of like really rapid evolution, especially in horses.
Mm-hmm.
So usually by like in between, CL1 and CL2, you'll have different species within the same genus. So for example, CL2 is known for having the species Pseudoparian gratum, while CL1 is more known for having the species Pseudoparian retrusum. So it's generally just based on what species you find, you're more likely to be in one of these sections or another.
Mm-hmm.
And with a couple of exceptions, most of the species are like really diagnostic of CL2. So if the cluster diagrams and analyses did not work out, there were other lines of evidence that would have made my discussion a lot more interesting.
Mm-hmm.
Because I would sort of try to figure out why it was not comparing well with these, why the statistics weren't working out, but the what species were there suggested why the two were different, basically. So I'd have to try and figure that out. If they still conflicted and I couldn't come up with a good reason, that'd be up to my committee. I mean, they ultimately decide whether I pass or fail my thesis. So if I don't know is an okay answer in science. You have to, kind of justify why you don't know, but that is an okay answer in science.
If assuming you did all the appropriate work correctly and all the appropriate
Right.
work led to an I don't know, that's in some ways that's almost a positive result. It's another question that we know needs to be answered, instead of a to take a Donald Rumsfeld saying it becomes a known unknown instead of an unknown unknown.
Well, there's several things that I think should also be looked at with this that were sort of outside the scope of this, like of my thesis. For example, that Pliohippus, that horse from this collection is weird. So Pliohippus, the taxonomy with Pliohippus is kind of a mess anyway, but we're fairly confident that sort of the evolution went from Pliohippus to Dinohippus, another genus of horse.
Right.
And then Dinohippus evolved into Equus, which are modern horses. So we're pretty confident in that sort of transition. And these teeth kind of looked like they were transitionary between Pliohippus and Dinohippus. And to my knowledge, I was not able to find like a species per se of Pliohippus that was transitionary like that. So
Wow.
that could potentially be a new species. That's outside the scope of my thesis to say. But they showed some features of Pliohippus and some features of Dinohippus. It's really hard to do that without a skull, though, because as good as mammal teeth are for, saying what species this is, a skull would be way better.
Right. If this turns out to be a new species, do you get to name it?
Do I? No, because I'm not publishing it.
Oh, this upsets me. All right, go ahead.
I would hope that they would talk about me in the acknowledgments, at least, or maybe, if they wanted to, get my opinion on some things and use some of my data, they could potentially have me as like a second author on a paper. That's not uncommon to have. In which case, I would probably have some input on what it would be named. Um, but
But it's not
honestly,
totally up to you.
right, yeah. It's whoever decides that this is worth looking into more. And then also, there's a whole subfield of paleontology called taphonomy. So which is weird because there's taxonomy
I was going to say,
with
I
an
thought, yeah.
with an X, and then there's taphonomy with a PH instead. So taxonomy with an X is how closely related different things are to one another.
Mm-hmm.
Taphonomy is completely unrelated to that, and that is the study of what happens to an animal from the moment it dies to the moment a paleontologist digs it up. Essentially, the fossilization process.
Hmm.
And, different environments have different taphonomic properties. Different environments preserve things in different ways. But generally, if fossils from different things are found in the same place, they're generally preserved similarly. Maybe not the same, but similarly.
That would seem to make some amount of
However,
sense.
yeah. However, I kind of noticed as I was going through that mostly with the horses, just because there's way more of them than anything else in that collection. Um, this species of horse, all of their teeth were preserved a certain way, versus another species of horse where their teeth were preserved a really different way.
Mm-hmm.
So, for example, one of the genera of horses that I was working with was called Neohipparion. Their teeth were all like a really kind of dark, glossy black color,
Okay.
whereas another species called Cormohipparion, their teeth were so a piece of like horsetooth anatomy is called cementum. Normally, it's only in like the roots around most other animals' teeth, but with horses, they sort of put that throughout the entire tooth to sort of reinforce it.
Mm-hmm.
The cementum on Cormohipparion was kind of like a white to almost like tinted orangey color
Hmm.
that was
Hmm.
not present in the cementum of any of the other horses. The enamel was also kind of uh, darker, like not the same color quite as like the Neohipparion that were sort of like the dark black glossy, but still dark. And it was a really weird contrast between that and like the white to almost orangey cementum.
And you said this
And
was like fossils that were all, that should have gone through close to the same fossilization process, right?
yeah,
So
yeah, all from the same spot.
that would indicate, I assume, something different about the taxa of teeth you're looking at, like from when they were, actually running around.
I have no idea. It could be the first thing that comes to mind would be just that they make their teeth slightly differently when it comes to like the chemistry of them.
Mm-hmm.
But these are fairly closely related horses, so that wouldn't make a lot of sense to me. And it wasn't just those two; those are just two examples that I happen to have off the top of my head. But it's almost looked like each species had really different preservation, and once again, completely out of the scope of my project. And I honestly am not all that interested in taphonomy personally. For no particular reason, I just don't
so,
find it all that interesting.
so there won't be any follow up to this paper where you investigate this
Not
further.
by me, but
Right.
I
Right.
really suggest to my advisor,
Somebody.
I'm like, this would be something cool for maybe like an undergrad or like a senior research student.
Mm-hmm.
Even just documenting it, because um, as descriptive as my paper is, that's not sort of what I was describing. So that'd be a really interesting thing to look more into, even if nothing comes out of it. But yeah, between that and the Pliohippus / almost Dinohippus teeth, just by me doing this, there's two more projects right there. So
Right. That would be cool.
yeah. And so, uh, as a result, we sort of reconfirmed that that this collection was from CL2, which is from about 11 or so million years ago, give or take a little bit.
Mm-hmm.
But yeah.
So that is, correct me if I'm wrong, that is kind of your thesis in a nutshell. And what I mean, is there anything else to say on the matter?
I could talk a little bit about the thesis process. I know we're close to an hour now, but I can talk a little bit about just sort of the thesis process that it went through very quickly.
Sure.
So, generally, a master's degree will take about 2 years, so 4 semesters. Your first semester, sometimes you come in with an idea for a project. A lot of times, especially for masters, you don't. Um, Generally, if you go for a PhD, you'll want to like come in with a project in mind. Uh, but for masters, that's not always required. And so I decided on my project, I think probably within the first 4 to 6 weeks, I think, of my master's degree. And then we actually had a class that was basically like intro to research at my school. So it's basically like how to properly do things. And so it basically, long
How to
story short,
properly do things.
yeah, that's not the
I
way
I
right way
would
to phrase
love
it, but
that. I would love that class. This is how we do things.
it was basically just laying out the process at our school
Right.
for doing your thesis. So, long story short, that class was mostly just to make sure you didn't procrastinate on your thesis proposal,
Mm-hmm.
which is something that you sort of refine over your second semester. And then you defend your proposal. You know, you write your proposal. Mine was about, I think, 14 or 15 pages. You defend your proposal to your committee, and they decide, cool, you are ready to actually do the research now. And so that is basically your first year. The second year is, and ideally over the summer, obviously this year with COVID, only so much of that could have been done.
A little more difficult.
I had planned to spend about a week at the American Museum of Natural History in New York City, looking at their collections. That
Mm-hmm.
obviously did not happen. And then as a backup, I wanted to go to the museum at the University of Nebraska in Lincoln, because they also have a really extensive collection, especially of like Great Plains stuff. That did not happen. So I was already sort of off on like the hind foot for some of my research, so that was kind of unfortunate.
Right.
But um, as soon as I got to campus in the fall, I went to work and started identifying those teeth, and that took me basically most of that semester into the beginning of this semester. And
Right.
then all of this semester, I gave my advisor a draft that was around 50 or so pages. At the first week of this spring semester. So I think like the third week in January, about 50 or so pages. The copy that I just received back from him, or well, just submitted to him 2 days ago, was 123 pages, which
So
it is abnormally long for a thesis to be that long.
is it. So
Um,
that's a long thesis. Okay, I wasn't sure exactly what the standard length was.
it varies wildly.
Mm-hmm.
Mine is so long because it's a descriptive paper.
Right.
Um, so there's a middle section that is called systematic paleontology. That is where I break down each group. So it's like, okay, carnivora, which again is all the carnivorous mammals. Okay, so carnivora, and then you break it down further. So then Canidae, and then subfamily Borophaginae. Then within that subfamily, there are these species. Then you break down the next one and the next one. And so out of the 123 pages, that is probably at least 70 of them. Probably
Wow.
more, realistically. Just because it is a really diverse, collection. We have everything from like those 7 or 8 species of horses, 3
Mm-hmm.
species of dogs.
What
I
you said?
think
What,
like
1,200
3.
fossils?
Yeah, so that does take up a lot. But the biggest thing is like if you have more species, that's just more entries into systematic paleontology that you have to like write about.
Mm-hmm.
Yeah, so 3 dogs, 1 anthocyanid, 1 cat, 7 or 8 horses. 8, yeah, no, 8 horses. It was 8 horses. 4 camels, 1 rhino, a tapir, some weird things that called oreodonts that we don't have anymore. Some peccaries, which are like the New World version of pigs, basically javelinas, if you've ever heard of them. And an elephant cousin. Not quite an elephant, but similar.
Not a mammoth?
No, so mammoths are basically elephants. They're in the family Elephantidae.
Gotcha.
Actually, they're even in the subfamily Elephantinae. So they're basically elephants. These are animals called gomphotheres,
Are they
who
as big
most
as
of
elephants?
them
Or were they?
roughly, like more or less, yeah.
Okay.
Uh, these ones were weird in that a lot of them had tusks on the bottom too.
Ooh,
Yeah,
that's something I'd
really.
like to see.
Proboscideans, which is the group that includes elephants and large animals with trunks, are just super weird. Everything about them is weird. So we could, if you so choose, you could suggest that in the forums down below. An entire episode about proboscideans. That'd be neat. I'd enjoy doing that.
Absolutely.
But yeah, just really diverse, and that doesn't even get into some of the microfossils. I did not do anything with the microfossils in this collection. For a couple of reasons, like time was a big one, just because you're on a pretty hard 2-year limit with a master's.
Right.
There's only so much funding to go around,
Mm-hmm.
Um,
Yeah. So going back to my question, kind of all the way at the beginning
oh yeah,
here, this was, this is basically 2 years of your life that you've really poured,
hmm
your heart and soul into, and now you've got, your 123 pages that you're going to be defending in. Was it April? You're going to be defending it.
yep. We're gonna try for the first week in April. The deadline is uh, April 16th, I think.
Okay.
Whatever that Friday in that area is.
Gotcha. And so you're going to be, and then like, do you find out that day when you defend it?
No, so we have to schedule ahead of time,
Right.
and we have to give our committee at least 2 weeks with the thesis to read it. Come up with any critiques that they might have before I defend it, and then I basically come up with a more or less half an hour to 45 minutes ish presentation about it. And then that is open to the public. And then that part closes, and then it's just me and my committee, and they ask me some of the more in-depth sciencey questions. And after that, there are 3 options. There is pass without revision, which like never happens. That's like 5%. Like I went to like a thesis workshop run by my school, and it was like that happens like 5% of the time. They were like, do not expect that to be
Yeah. Right.
the
If
case.
you don't get that, you
is,
didn't fail.
right. It's like, do not be disappointed if that's not you. There is pass with some revisions. So it's basically take the critiques from your committee, evaluate them, see, if they make sense. Usually they do, because frankly, they know more than you because they're actual, PhDs
Right.
and are just, have been doing this longer. You make those revisions, you resubmit it, they accept it. Cool. You're good. That happens the majority of the time. I would say, I think they said like, if pass without revision was like 5%, I think this was probably close to 60.
Okay. And so that's kind of, obviously you'd, love for this to be a perfect paper, but you're probably aiming for that in all likelihood.
Yes. Yeah. And then there is basically you need to redo your defense.
Is that a nice way of saying fail?
Yes.
Okay.
So you at that point, it's not like you need to choose a new project, but it's like there were serious flaws in the science that you did.
Right.
That your committee is just like, we can't let you publish this. You need to go back and you need to fix this.
And so
that happens. What was that? The remaining like 30 or so % of the time?
Right. Whatever percentage is left.
Yeah.
So if you were to say about how much, what percentage left do you still have to finish up? I know that you are mostly, but not completely done with this thesis? What how much work is there left to do?
Well, my advisor just sent me an email this morning, so I'll take a peek at that. Live, just reading emails. What an interesting podcast.
It's great radio.
Let's see.
Well, in the meantime, while you are finding that, I will just say that this has been something I've wanted to know more about for quite a while. I know you were doing something on horses, and that was kind of the extent of my knowledge. And so, just kind of hearing the nitty gritty science that's going into this, that probably isn't going to be made into a feature film one day, but is nonetheless just like it is the kind of we all stand on the shoulders of giants. It is the kind of research and the kinds of ways that we understand the planet that seem small or may seem insignificant at the time, and yet when taken in totality really add to our understanding of our own existence. And so I was excited to hear about this, and this was a lot of fun to hear about just the different ways that you had to go through and do all this kind of grunt work. So just with all of that, this was a lot of fun to listen to, because I know in particular with this episode, this wasn't just an episode that you did some research and we recorded for a podcast. This is something you've spent the last 2 years specifically of your life really digging into, and you went to college for 4 years before that. 5 years before, excuse me, 5 years. I apologize. Before that, to do all this. So it is just kind of the culmination of all this. I know it's gratifying for you, and is a lot of fun for me just to be able to listen to you talk about it. So thank you very much, and I will let you get to that email now.
Yeah, of course. Obviously, like I said, this has been 2 years of my life. I want to talk about it, so I didn't just feel like I wasted the last 2 years of my life. But among other things in the email, I'm not gonna read the whole email. But so he basically just says, looking through it quickly, he says, the cursory overview looks good. My figures look nice. Thanks. He said, go ahead and schedule your defense for early April. And then he said, I'll get this back to you as soon as possible, with just a few edits, and you should be able to distribute it to your committee. So that to me just sounds like
pretty big weight lifted off your shoulders.
Oh, absolutely. Especially in light of what Mike and I had a conversation before we started. I had a trip planned for spring break that I was so stressed about finishing my thesis over that I ended up canceling. And then he sent me that today, basically being like, hey, you're good. And then I was like, well, and I explained to him, like, I had this trip planned, I canceled it. Do you think I'm at a good enough spot where I can uncancel that trip? And he's like, yeah, absolutely. And I'm like, okay, cool. So
bye. So
pretty much, because spring break is next week, actually, at the time you're hearing this.
Well, lucky for you. That is great news, kind of all the way around for all of that. So, is there anything left to say on this, or are we ready to kind of close the book on at least for now? I'm sure we can revisit it another time, but are we ready to close the book on your master's thesis?
Oh, I have much more that I could say about my master's, but some good, some bad. But overall, it's been really rewarding, if not also one of the most stressful and stress-inducing things I've ever done. So,
and what is grad school if not both rewarding and incredibly stressful?
Yeah, exactly. But
well, that is wonderful. Thank you very much, Gavin. This has been episode 12 of I Wish You Were Dead, a podcast about things that used to be alive. Gavin has finished his master's thesis, and I think that'll be our title with a little asterisk on it, just acknowledging that you still have to, fix a few apostrophes or something. But I think that is our episode. Thank you very much, Gavin, for sharing all of that with us.
Of course, Mike. Thanks for putting up with me, I guess.
I will put up with you any day of the week. Take care, everybody.